What I'd like to do in this video is demonstrate how to model 213005A using reference planes and convert entities as a companion to our textbook tutorial. Here's the drawing for the part. If you don't already have it open, it's a good idea to have your textbook tutorial on page 60 open while you watch this video. And again, as a reminder, due to the new skills being introduced in this video, you should watch it once all the way through without following along, and then a second time, pausing after each section to follow along. To start this part, open SolidWorks and start a new part with IPS units and the ANSI standard set. Start a new sketch on the right plane in preparation for a revolved feature. Sketch the top half of the outline of the part shown in the right view of the drawing without the cam lobes. Remember that you need a center line in your sketch. The one for this part goes best horizontally from the origin. You can also try using the infinite line option, as I'll demonstrate here. Be sure in your revolve sketch that you make the top horizontal lines collinear and equal to each other to fully define the sketch. Revolve your sketch 360 degrees. I also decided to add a reference dimension by making the dimension, confirming it to be driven, and changing it to reference by putting parentheses around it from the property manager. Activate the reference plane command from the drop-down of Reference Geometry on the Features tab of the Command Manager. Click the right face of the leftmost journal bearing and create two offset planes that are offset 1 inch. Start a new sketch on the leftmost plane of the two you've just created and draw the lobe sketch. You should start with the 1.125 inch diameter circle at the origin and a smaller 7/32 radius circle directly above it. Use a vertical center line to ensure the two circles are vertical. Then, Draw an arc on one side that is tangent to the two circles and has a radius of 2 inches. You can then mirror the arc to the other side using the vertical center line. To get the 1.468 dimension to go to the maximum arc distances, you will have to select a dimension, switch to the Leaders tab of the Property Manager, scroll down to the bottom, and switch both the first and second arc conditions to max. When everything is fully defined, trim away the excess. Trim in a chain sequence as to not eliminate any relations that you added. Extrude the cam lobe using the mid-plane option for the boss extrude direction to 0.5 inches. Confirm the boss extrude. Now start a new sketch on the right reference plane of the two you added. Click the right surface of the cam lobe you've just created and click the Convert Entities button from the Sketch tab of the Command Manager. The outline of the cam lobe should now appear on your new sketch plane. Convert all the entities you've just retrieved with Convert Entities to construction geometry. Draw a horizontal center line from the origin of the sketch to the right. Activate the Sketch Mirror command and mirror the lobe sketch entities across the horizontal center line. After performing the mirror, convert the mirror entities to solid lines. Then extrude to 0.5 inches using the Extrude Midplane option. Create a reference midplane using the rightmost and leftmost faces of the camshaft. This will put a new plane directly in the middle of the part. Then activate the Hole Wizard to place a 5/16 countersunk hole on the right end face of the camshaft directly in the middle on the origin, having a depth of 0.5 inches. Be sure to check the hole callout in the drawing to ensure everything is specified correctly. Use the mirror feature and the new midplane created to mirror the countersunk Hole Wizard hole to the other side. Hide all reference planes by left-clicking them and choosing the eyeball with a slash through it from the context toolbar that appears as you select each reference plane. Add the fillets and chamfers using the 3D fillet and chamfer tools as specified in the drawing. The fillets are on every concave edge and the chamfers are on all the journal bearing surfaces.